there's a couple of different things to look at to understand the climate of a region and to see how the climate impacts upon production. So one of the first steps in approaching a holistic design is really to understand the characteristics of a site well, and one of the main characteristics of a site would be the climate. So that's things like the temperature, the rainfall, the elevation, the distance inland, and the wind speed and the number of frosts that a particular site experiences during a year. And all these factors will determine the growth of plants within that system and also the health and the productivity of the animals within that system. So matching up the plants and animals that are most productive for a particular climate is one of the most logical and best first steps to be able to set up a really productive and sustainable organic agricultural system. So a little bit about the background for understanding a climate for a region. The climate's really the movement of the atmosphere and the movement of the ocean, and there's currents both within the atmosphere and the ocean that drive and influence our climate, and they result from the uneven heating of the ocean and the atmosphere in the equator, where the Earth receives most of the heating from the sun. So when you look at the heat that the Earth receives from the sun, it receives most of the heat around the equator, and then increasingly less heat towards the poles, so in the south and the north poles. And what that does is it creates these currents within the ocean and within the atmosphere, where as the water and the gases in the atmosphere are warmed, they rise up, and then as they rise up they cool, and then they start to sink down again. And the reverse pattern plays out on the poles, where the hot gases in the atmosphere and the hot water in the oceans cools down at the poles and sinks and is pushed away from the poles. So that creates all these flows within the atmosphere and within the oceans, which drive our climate. And depending upon what the particular dominant flows are in your particular region will have a big influence on your climate. So some areas like England, for example, would be a lot colder than what they currently are if they didn't have a warm ocean current moving past them. And New Zealand, to a large extent, particularly the South Island, would be a lot warmer than it is if it didn't have these cold currents moving past it. So in New Zealand, the dominant currents we get is a northwesterly wind current. So that's due to the atmosphere being warmed in the equator and then being pushed down south. So it's coming from a northerly direction across New Zealand. And as the Earth is spinning in an easterly direction, so as the Earth travels through space, it's spinning in an easterly direction. That takes the winds that are coming down from the north and it twists it to create a dominant northwest wind, which is what we experience as our dominant wind in summer and spring and autumn. But in the south, when we're getting stronger winds coming down from the poles, our dominant wind changes to a southerly wind. So those two winds have a big impact on the temperatures we experience in New Zealand, and the northwesterly wind keeps it quite warm and moderate during spring, summer and autumn, and the southerly wind cools it down in summer. And in a similar way we get similar patterns in the ocean. So in the summer and autumn we get warm northerly currents moving past New Zealand, and in the spring and winter we get cooler southerly currents coming past New Zealand, and again those ocean currents impact the temperature of the ocean and therefore the temperature of our land. So that's a bit of a background as to why we get the climate we have. And they create characteristic patterns depending upon where you are in the world. So in New Zealand we're bordering the kind of the warm temperate, and down the bottom of the south the cool temperate zones. So if you're in the tropical zone of the Earth, you have quite a characteristic climate. You get 12 hours of sunlight and 12 hours of darkness, and during the whole year it's around 25 to 35 degrees Celsius, so it's quite stable in the hours of sunlight and the hours of darkness, and it's also quite stable in its temperatures. But the further you go away from the tropics, the more extreme the changes get as far as how light it is in summer and how dark it is in winter, and also how cold it is in winter and how hot it gets in summer. So in New Zealand, we're not too far away from the equator. We're about 25 to 35 degrees latitude. So in that range of latitudes, we kind of go into the quite warm temperate climate, so the Mediterranean climate, and then down the bottom of the South Island we're getting into the cool temperate climates, which is more like England and southern Europe, and what the temperatures are like. And what it does as you're moving away towards the poles is it creates more extreme changes within the seasons. So the seasons are actually created by the tilt of the Earth. So the Earth isn't just up and down, it's actually tilted a little bit to the east. So when it's summer, the northern part of the Earth is, when it's summer, the southern part of the Earth is tilted towards the sun and it's receiving more sunlight, and that's our summer. And then as it moves into autumn, it's more equal in distribution between the north and the south. So we get more like the equator, we get 12 hours of sunlight and 12 hours of darkness. So that's our autumn equinox. And then as it goes into our winter, we get we're facing away from the sun, so we get a lot less sunlight, so we get longer nights and we get shorter days. So these are long nights and short days. And on the shortest day, that's called our winter solstice. And then as the Earth continues to orbit around the sun, it then goes into another spring equinox, so where we get again on the equinox itself 12 hours of light and 12 hours of darkness. And then in the summer solstice we get again longer days and we get shorter nights. So depending upon where we are in this orbit around the sun will determine what our season is, and will also affect the temperatures and how much light. And plants have evolved to respond to this, particularly in these more temperate regions away from the equator. So plants will flower in response to increasing day length, they'll fruit as the temperatures warm up. So they've evolved adaptations in response to this. And those evolutions and responses of the plants are also of importance to our agricultural production. So these are the factors that affect our climate, and then if we're trying to understand the characteristics of the climate of a particular location, it comes down to things like how high it is, how far inland it is, what is the rainfall of that region, what is the temperature of that region, how many hours of sunshine it has, how many days of frost it has, and all of those particular values will then guide you as to what is the most suitable plant or the most suitable animal to grow in that region. And there's quite a good database in NIWA which will give you maps that will indicate the hours of sunshine and rainfall and days of frost for a particular region, and then you can look up the information for that particular plant that you want to grow and see if there's going to be enough sunlight in that region for it to be able to fruit well. If that region doesn't experience damaging winds that could affect your production, if that region has the number of frosts which would suit its production. So some stone fruit, for example, light frost, and apples and pears will produce better if there's 10 or so days of frost a year. But more subtropical fruits can't survive frosts very well. So if there's more than a few frosts a year for those more sensitive subtropical species, they won't grow in those regions. So having an understanding of these factors will help guide you as to what is the most suitable plants and animals for production at that site.